Good afternoon, students. The few students have joined. Anyway, we can start. I hope some more students will join. Okay, first we will look at the answers for the CA1 quiz. Okay, then I'll spend time to clarify your doubts, if any. Okay, Benita is asking if there is another day for quiz paper collection. So if you did not collect the quiz paper, can you send an email to the graduate assistant? And you can go to the ComNet lab and collect it. Just drop him an email. You can collect it from him. Just a minute, let me share the PDF document. Students, oh, sorry, it's a wrong document. Okay, students, can you see the quiz paper? Hello. Okay, yes. Okay, to save time, okay, so I earlier worked out the answers, but let me explain it quickly. Question number 1, how many 1000-bit frames can be transmitted in 1 second on 1 Mbps link? So it's a quite straightforward question. The link capacity is 1 Mbps, that is 10 raised to the power 6, and the frame size is 1000 bit. So how many frames can be transmitted would be the bandwidth divided by the size. Is that okay? So the answer would be 1000. That is B. It's a quite straightforward question. I hope everyone got it correct. Now, question number 2, with ADSL, the best achievable throughput is not the same for upstream and downstream data transfers. So this is true because this is asymmetric DSL, okay, even cable modem as well. Usually the downstream data rate is higher than the upstream data rate. So that implies the throughput or the best achievable throughput on the downstream side, that is when you download, is more when compared to the throughput which when you download your files, okay, to a remote server. So upload throughput is smaller, download throughput is bigger. Okay, so both are not same. Now question number 3, which of the following statements is true? There is no congestion at a switch with fixed TDM. That is true because all the bits which arrive in a given time, let's say 1 second, are guaranteed to leave at the output within 1 second in the case of fixed time division multiplexing. So there is no congestion. Okay, there is no question of a lot of excess bits queuing up at the TDM, fixed TDM switch. That is true. So just don't take A. You need to read through all options. Okay. Move on to option B. Total channel bandwidth is shared among the users when FDM is used. That is also true. Okay, so if, okay, let's say 10 megahertz channel is used on frequency division multiplexing by, let's say 10 users, then everyone will get a share of 1 megahertz. So that means the total bandwidth is shared. Now, option C, using ARP, a host in a network finds the hardware MAC address and IP address of every other host in the network. That's also true. That's what the address resolution protocol ARP does. So the answer would be D, all of the above. Question number 4. So if you have any doubts which need quick clarification, you can stop me. Otherwise, wait until I complete. Okay, you can ask your doubts. Which of the following statements is false? That is question number 4. A TCP segment is encapsulated into an IP packet. That is true, right? That means if you take an IP packet, so IP packet as L3 header, that is IP header, followed by the TCP L, that is TCP header, and the payload. That means for IP packet, the payload for IP packet is nothing but the TCP segment or UDP segment. So we say that TCP segment is encapsulated into an IP packet. So that is true. B, BER, that is bit error rate or bit error ratio, whatever it is much smaller in passive optical network SPON than cable modem based access network. That is true. Because when we use fibers, the bit error rate is less than 10 raised to the power minus 12. When we use copper based network, let's say cable modem or ADSL, etc. So that kind of links will have BER less than 10 power minus 6. So BER in the optical network is much smaller. That is true. TCP runs on top of IP in an IP router. TCP runs on top of IP is true, but that happens only at the end host, either computers or servers, because TCP is an end-to-end protocol that is running at the source as well as destination, or sender and receiver. TCP will not run on inside the IP router. So the option here is TCP runs on top of IP in an IP router. That is false. Okay? Flow control is a function of layer 2 as well as layer 4. That is true. Even though it is optional, okay, it is defined for both layer 2 as well as layer 4. So that is true. So the answer, or the most appropriate answer, is C. Now question number 5, the acronym MAN stands for, I think this is the easiest question. Okay, I believe everybody got it correct. So this is Metropolitan Area Network. That is B. Now question number 6. The CRC computed for the message using a divisor polynomial x squared plus 1 is. Okay. That means you are given the message and you are asked to find what is the CRC bits. The divisor polynomial is x squared plus 1, which is nothing but 101. Okay, so this is 1. There is no x term, and there is a constant term 1, so it's 101. So what we need to do is, first you need to, so the message bit is 111011. You need to add 2 zeros at the end, because the divisor polynomial has 3 bits, the remainder will have 2 bits. Okay, that means here k, that is the degree of the polynomial, is 2. Now divide it 1, 101, 101. So 1 minus 0, 1, 1 minus 1, 0. So there's a leading 1, that's fine, but we have only 2 bits. So you need to bring this 0 down. Okay, so okay, it's overwritten here. So there's a 0 here. Okay, this 0, then 1, 101. Now, when you subtract 101 from 100, you get only 1, single one. Okay? So you need to bring 2 bits down. That means these 2 bits are brought here, 1. Okay? Because you need to bring 2 bits down to make it 3 bits, starting with 1. Okay, 0 followed by 1 here. Okay, now 1, 0, 1, 1 minus 1, 0, 1 minus 1, 0, 1, 0 minus 0, 1. So this is 1, 0. So now bring this next bit 0 down, 1, 1, 0, 1. This is 1. So next you bring this 0 down. So in the question we have another 0. So let's not worry about it. So the answer is 1, 0. So C is the correct choice. Again, please note that we are not interested in the quotient. So the remainder is important. Okay? Even in the test or exam, in the exam, even if there is a question, you need to show the steps clearly. Question number 7. It's required to send 100 bytes using PPP framing with byte stuffing. What is the minimum and maximum number of bytes that would be transmitted to the case? Okay? Because it uses byte stuffing, in some cases, okay, we have to, because when the flag bit appears here or flag byte or escape byte appears inside, we have to send 1 extra byte, right? So the best case is, okay, we don't need to add any extra byte. So the smallest one would be 100. What is the worst case? Worst case is for every byte, you need to send 1 additional byte. That means 2 times. So the answer is 100, 200. Question number 8. 2 hosts A and B attempt to transmit on an Ethernet. Each host has a steady queue of frames ready to send. At a given instant of time, the 2 hosts attempt to send their frames simultaneously and a collision occurs. It's a similar question as what we did in the tutorial. We say that the hosts enter into a backup race. Suppose this collision is the 3rd collision for A and 1st collision for B. What is the probability that host A wins the race? The host is said to win if it transmits its current frame successfully before the other host and also before any other collision in the network. This is the same definition as what we have seen in the tutorial problem. So there are 2 hosts. For A, this is the 3rd collision. That means A will generate a number from 0 to 7, or it chooses a number randomly from 0 to 7. It's a 3rd collision, right? And for B, it is the 1st collision. So it chooses a random number from the interval 0 to 1. So total number of possible pairs is 8 times 2, that is 16. Now we need to find the cases or the scenarios, okay, for which A will win the race. A wins the race, okay, when, let's say we check 1 by 1. When A gets 0, B should get a number greater than 0. Okay, if it also gets 0, then there will be collision. So there is only one such combination or one such pair of value, 0, 1. Now, how about the other cases? When A gets 1, then B should get a value greater than 1. That is not possible. So such cases would be 0. So in only one case, A will win the race. Okay? So the answer would be 1 out of 16 possible combinations. So for one combination, that is A 0, B greater than 0, that is 1, A wins. For all other pairs or the combination of the 2 values, okay, B will win, or there will be further collisions. Question number 9. Consider a sliding window-based flow control that uses a 3-bit sequence number and a window size of size 7. At a given instant of time, at the center side, the window is 1. Window size is 1. And it contains frame sequence number 5. That means frame 5 is the next frame which is permitted to send, and it can send only one frame 5 before waiting for an acknowledgement. If some acknowledgement is received, it can expand the window and it can send more frames. Now the sender receives RR4 and updates the window. What does the new window contain? Okay. Now, the window has 5. And okay, first step is you find the outstanding frames. The maximum window size is 7. So now window has only one element. So that means the outstanding frames, number of outstanding frames is 6. So what are those 6 frames? The earlier or the previous frames. Before 5, 4, 3, 2, 1, 0, 7 were transmitted. So these 6 frames are the outstanding frames which were transmitted, but the acknowledgement not yet received. Now the problem states that sender receives RR4. So when it receives RR4, that means it acknowledges all the frames prior to 4. That means frame 3, 2, 1, 0, 7 are acknowledged. That is 5 frames are acknowledged. So window will expand by 5. So now it has 5. So another 5 elements will be added here, 6, 7, 0, 1, 2. Students, is that clear? Any doubt? Students, can I move on? Okay. Question number 10, the maximum number of bits that can be transmitted in 1 second. That is, what is the upper bound? Okay, how many bits we can transmit at the most in 1 second if 8 megahertz wide TV channel is used in a network link. Sorry, as a network link is approximately dash Mbps. So approximately how many million bits per second can be transmitted on a TV channel link whose bandwidth is 8 megahertz. So in this case, we are given bandwidth in hertz, that is 8 megahertz, and we are asked to find the capacity, that's the maximum bit rate, okay, which that is maximum bit rate that is possible for that particular channel. The answer is 8. How we get this 8? So here is the formula, the Shannon capacity theorem on the limit, that is the capacity, how to find the capacity, that is C equal to B log 1 plus S over N, and log here base is 2, C is the capacity in bits per second, 8 is the bandwidth in hertz, S over N is given in decibels usually. So it's given that signal to noise ratio is 30 dB. So 30 dB means what? 10 log S over N base 10. Please note that this is base 10 equal to 30. So 0, 0 will cancel. This will become 3. So S over N is 10 cube, that is 1000. That is approximately 1024. That is approximately 2 raised to the power 10. Because I'm not using 1000, I'm using 1024. I say it is approximate. Why I'm using 1024? Because the formula uses base 2. So 1 plus s over n is approximately 2 raised to the power 10, whether it's much bigger than 1. So log 2 power 10 base 2 is nothing but 10. So 8 into 10, 80. That will be Mbps because 8 is in m megahertz. So the answer is 80 Mbps. Question number 11. Assume that host A is transferring a large number of frames to host B using sliding window protocol through 200 kilometer long 100 Mbps link with a propagation delay of 5 microseconds per kilometer. Assume that each frame carries 1000 bytes of data and the communication is free of errors and every frame is individually acknowledged. Which of the following would be your choice for the window size to achieve maximum link utilization? Okay. So you are given different windows. So which window size would be your choice? Okay. Now, we know that the utilization is maximized. Maximized means utilization will be 1 when W is greater than or equal to 1 plus 2A. Obviously, we don't want to have large W because W implies that the amount of buffer which you need. Okay. So we want to find the minimum value of W for which the utilization is maximum, that is utilization is 1. Okay. So it's the usual steps. First find TP. So 200 kilometer long, the propagation delay on each kilometer is 5 microsecond. So TP is 1 millisecond, 5 into 200,000 microsecond, that is 1 millisecond. TF, frame transmission time, the size is 1000 bytes, 8000 bits. Note that you need to convert it into 8 bits. Divided by 100, 100 is 100 Mbps. So it's equal to 0.08 millisecond. A, TP by TF, 1 divided by 0.08, it's 12.5. Now, the window should be greater than or equal to 1 plus 2A. 2A is 25, 1 plus 2A is 26. Is that fine? So the answer is 26B. 12. Assume that host A is transferring a large number of frames to host B using a sliding window protocol through 90 kilometer long 10 Mbps link with a propagation delay of 5 microseconds per kilometer. Assume that each frame carries 125 bytes of data. Window size is 10 and the communication is error-free. How many frames are sent in 1 second? Okay, so somewhat related to the previous one, but now we are interested in finding number of frames. Okay. Okay, as usual, we calculate TP. TP is 0.45. How we got it? Because 90 kilometer, 5 microsecond per kilometer, that is 440 microsecond, it is 0.45 millisecond. TF 1000 by 10, that is 100 microseconds, that is 0.1 millisecond. W is 10. And W is 10 and number of frames per second. Okay, before that, I think you can try to find out what is 1 plus 2A. I mean, that step I have not shown here. Okay, so what is A here? A is TP by TF. Okay, so A is TP by TF. So A is equal to 4.5. W is equal to okay. So in this case, of course, you can use both formulas. It's exactly W is 1 plus 2A, right? So number of frames per second, you can find in two ways. That is, one way is because W is equal to 1 plus 2A. Okay, so utilization is 1. Utilization is 1 means the frames are sent continuously without any gap. So number of frames per second would be 1 divided by TF. So 1 divided by TF, that is equal to 1 equal to 1000. Okay, that is 10,000. Sorry, 10,000. Because 1 divided by 0.1 millisecond, millisecond is 10 power minus 3. So denominator you have 10 power minus 4. So overall it's 10 power 4. Of course, I used this formula, but be careful to use this formula. So in this particular case, it so happens that W is exactly 1 plus 2A. W is exactly 1 plus 2A. So the answer you get it same. But if W is greater than 1 plus 2A, let's say window size is 11, then you have to use this formula. Is that okay? Okay, is that clear? So you need to check whether W is greater than or equal to 1 plus 2A or less than 1 plus 2A. And this formula is used W is less than 1 plus 2A. But when it is the same, of course, the value will be the same. That is here W 1 plus 2A and W is the same. But I would rather suggest to use this when W is greater than or equal to 1 plus 2A. Question number 13. A switch has 4 ports labeled 1 through 4. It receives a frame from host 1, H1, on LAN A via port 1 destined to host 2 on the same LAN A. That means host 1 and host 2 both are on the same side, on the same port, right? So no need to forward it. There's no need for the switch to forward it. But the question is, which of the following cases the switch will not forward the frame? So the switch should know that H1 and H2 are on the same port because it receives the frame from port 1 and the sender is host 1. Now it knows that host 1 is on port 1, can be located on via port 1. But it will know that host 2 is also on port 1 only if it has a forwarding table entry for host 2. Only in this case, it will not forward the frame. It just keeps quiet. Right? So the answer is C. Number 14, suppose the frames are transferred on a link using go back NIRQ with a window size 7 and frames are numbered 0 to 7. The receiver sent RR4 and the sender, to the sender, which was lost. The receiver then received frame 4 and frame 5. Okay. That is, the receiver has sent RR4, which was lost. So receiver doesn't know about it. Sender also doesn't know about it. Yeah. But the receiver receives 4 and 5. And it completes its processing. 4 and 5 are done. So now it receives an RR command frame, that is the probe frame. Now sender is probing receiver what's happening. Okay, then receiver has to respond with a new RR frame. Okay. Now the question is whether it will repeat the previous RR frame 4, okay, or it will send something else, right? So for some reason, sender is probing, could be that the previous RR4 was lost, but at the time of receiving this RR frame, the receiver has already received 4 and 5 and completed the processing. So what it will send is, it will send RR6. That is, it implicitly says that it has received until frame number 5. Okay. Now, question number 15. Choose the incorrectly matched pair. So which pair is not matched correctly? Ethernet switch, packet switching, that is correct. True. Ethernet hub layer 2 forwarding, that is false. Hub is not a layer 2 device, because layer 2 means it has to look into layer 2 header and process the frames at layer 2. That is done by switch. Switch is a layer 2, but hub is below layer 2. You can call layer 1 device. Okay. So this is false. Ethernet switch, CRC based error detection, that is true. Ethernet hub, single collision device, this is also true, because all the hosts which are connected to hub, they are put in the single set. That means they can possibly collide with each other, and anyone can collide with anyone else. There's a possibility. So all are put in one set. Yeah. So this is the end of my presentation. Okay. And if you have any doubts on these quiz questions, first you can ask. Then we will move on to other questions if you have any on part 1 topics. I'm not going to post. Okay, the recording will be posted, but I'm not going to post the answers. If you wish to review the answers, you come back and watch the video, recorded video. Okay. Okay, students, now time for Q&A, time for questions. Questions from you, answers from me. Any questions?
Prof, I have 7 questions.
You have 7 questions, sir.
Yes.
Okay.
I can slowly ask, or if anyone has, they can go first.
Okay.
Yeah.
Shortest number first. In operating system, that is policy, shortest job first. So he doesn't want to hold for a long time. Okay. So other students who have questions? Q4, can there be a case where the IP router is the source or destination? No, when you say host, which runs app, that's the host. So IP router is just a router. It's not hosting any applications. That means you can connect to a server. You can get some data, store some data, get some data or some service from the server, not from the router. Okay, is that clear? Others? Hey, Prof, could you please upload the Zoom recording for lecture note 6? For lecture note 6, there was a lecture venue webcast. Then some part was pending. I took a Zoom class along with the special consultation session for the midterm sample questions, right? Okay, let me check. So you are not able to see the recording? Okay, I'll go and check. Because we are new to Canvas, I have to go and check the test settings, right? So Canvas is new to us. I don't know the difficulty, because it's new, we are not aware of some settings. We think automatically it's available, but it's not available, it looks like. So after this session, I will go and look into the settings. I believe you should be able to see the recording, the previous Zoom recording as well as this Zoom recording. If you have any issues, you let me know. So wait, okay, until today evening. If you cannot see, please drop me an email. Students, other students, any questions?
Prof, I ask first, but
Okay.
in one of the question about the sound to noise ratio, right?
Yes.
I'm just wondering what's the difference between the sound to noise ratio given in the question and the sound to noise ratio that we are expected to find?
It's a signal to noise ratio. Signal.
Yeah, sorry,
Then,
yes. What's the difference?
difference between?
The signal to noise ratio that is given in the question and the one that we are expected to find.
Okay, so you can see that there are three variables, right? C, B, and S over N, right? There are three variables, correct? If two are given, you can find the other one. Right? Very simple, right?
Yeah.
So, but in this case, two are given. For example, 8 megahertz wide bandwidth B is given, and signal to noise ratio is given 30 dB. So two are given. We calculate the third one, C. So if let's say C and B are given, you can calculate S over N. Right? Similarly, if C is given and signal to noise ratio is given, you can find out D. What's the band?
Why do we pass the signal to noise ratio into the 10 log 10 S over N equals?
Because the convention is the unit is dB.
Oh.
Unit is decibel, dB. dB means 10 log 10.
Okay.
That's a convention unit, because this is not the actual signal to noise ratio is 1000. But instead of giving 1000, they express it in dB. That's a convention. So you need to convert it into a normal unit, 1000.
Okay. Then will token rotation time and VCI table be tested? Because I noticed that it was tested in the 2001 paper. I don't know whether
token, ring, and FTDI, okay, they are out of scope.
Okay.
The ring is, yeah. What's the other question? You said two topics, right? Token ring and another one?
VCI table.
Yeah, VCI table also, yeah.
Okay.
That is out of. I don't know whether it was covered in the second part. Was it covered in part 2?
I don't think so.
And then it is not. Okay.
Then will I think one person mentioned just now, the chapter 6,
Yes.
will it be tested? Because it wasn't, you didn't really go through it in lecture and there wasn't any tutorial about it.
It will be tested. I think there was one tutorial question, if I'm not wrong. Right? I think there was one question. There is one tutorial question in the last tutorial 4. This will be tested. Only thing is, some recording is not accessible. That's what students are saying. I will make it accessible. I'll go and check the canvas. It's new to me. I thought you are able to access it. Nobody fed back to me so far. So now I understand you are not able to access it. I'll go and investigate the settings.
Are there any more recent past year papers that you can provide for us? Because the ones that you provide is like more than 20 years ago.
Okay, many topics, okay, are more than 20 years old. Okay, right? And several questions, they come in some form or other form in tutorial as well as sample questions, quiz questions. Do you get this point? Even though we didn't release it, some form or other form, they were captured in the tutorial as well as test questions. But still, if anything is needed, I need to consult with other lecturer. Okay, because those questions which I released at that time, I was teaching the course. Okay, I was teaching the module, and during this time, I think TCP was not there, if I'm not wrong. Okay, and the course was until IP, ATM, those things were there when I was teaching it alone. Yeah. But don't worry, all the questions, recent past question also, the concept, okay, was captured directly or indirectly. They were captured in the tutorial questions, sample questions, quiz questions, I mean these questions, etc. Okay.
Is it okay to provide solutions for the 3 past year papers that you provided? Because some questions were covered in the tutorial, but there were also some that were not covered.
Okay. As a general policy in the department, we don't release the answer. I mean, the idea is to let the students practice rather than what I say, give, okay, this is the answer and all. But I would encourage you to work out, okay? And if there is any difficulty or anything, you are free to discuss with me. Okay. Is that okay? Did you try? Did you try? Any problem?
I tried the first one, the first paper already.
Okay.
Okay. Then there's one more question from the first year paper. In the first past year paper, they wrote that host A and host B, they enter a back-off race and they have 4 collisions, but then host A won the first 3 collisions. So I was wondering, will the number of slots that host A can choose from reset to 2 every time it wins, or will it just exponentially increase?
Okay. So this point I would like to clarify it. Okay. So that is 2001 question, is it?
Yeah.
Let me pull out.
And how do you calculate the probability? It's in the question 3, part 4.
Okay, I can tell how to approach this. Okay.
Yeah.
1 minute. Just a minute. Can you see? Question number 2001,
Yeah.
right? This question, right?
Yeah, part 1 and part 4.
Okay, so A and B are trying Okay, so they are the race, right? And it says, let me use my pen. So it says host A wins the race, 1, correct? The above, sorry,
Then it repeats and wins all the other 3.
suppose that A and B, okay, let me read from line number 3. Attempt to send frames, let's say A1, B1 is sent, they collide. When they try again to transmit frame using exponential backup algorithm, host A wins the race. So we say host A wins backup race 1. The above procedure repeats, and suppose that host A wins and host B loses all the first 3 backup races, that is race 1, 2, and 3. Now A and B collide again, enter into race 4, right? So in this case, it is race 4 for us when we are trying to solve it. But as far as A is concerned, because it is winning every time, the collision count will be reset to 0. Okay. So that means when there is a 4th collision in race 4, when in race 4, for A, it is the first collision. For A, it is the first collision. And B, it is the 4th collision. Correct?
Yes.
So I think then answer 1, part 1 is straightforward. What is the minimum maximum number of slots A waits? Correct? Because this is the first collision for A. And part 2 is the 4th collision for B. Part 3, you know how to calculate the winning probability for A, correct?
Yes.
Now part 4, okay, what is the probability that host A wins race 4 and all the remaining races? Okay. So this is also a simple question only. If you look at carefully, because you try race 1, race 2, race 3, race 4, okay, and you'll get some fractions. Okay, let's say race 1, you get, maybe I use text. For race 1, you may get A1, something like B1. Answer for race 1. For a race 2, you may get some number A2 divided by B2. For race 3, A3, there will be a fraction B3. And for the 4th race, it will be A4 divided by B4. And if you look at these fractions, you will see the pattern. You will see a pattern. Okay. So once you see this pattern, even in fact, after 1 or 2, you can see the pattern. So you can easily guess what is A5, what is A6, A7, what is B4, B5, B6, right?
Yeah.
So because the answer you are asked is approximate value, so you can just say that it is A4 by B4 multiplied by A5 by B5. What is A4, A5 you need to calculate, right? A6 by maybe B6. Maybe then you can leave ... Okay. Do you get this point? But you should not explicitly calculate what is A5, B5. By looking at the pattern, you can easily guess what is A5, what is B5. It will follow a pattern, right? Other possibility is you can give in sigma notation, okay, something like n equal to 4 to infinity or 1 to infinity. You can give a simple expression. When you solve this, you'll see that the pattern, you can easily understand the pattern, because every time will be the first collision for A, and only for B it is changing, second collision, third collision, fourth collision, fifth collision, etc. Okay?
Yeah.
Okay. Next, 7th question. This is 6th question or not yet?
Is it mostly answered? There's one more question. Question 5A.
Okay.
IP is related to IP though. Okay, I'll try to ask. 5A.
Yes.
Is this out of scope, like the probability of loss? IP.
So, I mean, that you need to check with the other lecturer. Okay. For me, I mean, this is simple probability question. Okay. IP packet is fragmented into 10, right? That is, you have F1, F2, up to F10, right? You have 10 fragments, right? And it is transmitted twice. That means there are also fragments F1 dash, then F2 dash, then F10 dash, right?
Yes.
So the question says, what is the probability of net loss of the packet if the packet is transmitted twice, assuming any given segment may have been part of either transmission? That means what it says is, it will be successful, right? Better you work with AND in the probability rather than R, okay? Because they are independent, right? F1, F2, F3 are independent events, okay? That's what it is given, independent of others. So if it's independent, then P of AB is PA, PB. It's a multiplication. Of course, sometimes you can work with addition also, or also A union B. But in that case, P of A plus P of B minus P of A intersection B you should do. Okay, that would be sometimes confusing. I will always ask students to work with AND. So it asks you what is the probability of loss. Maybe you find the probability of success. When it will be successful, okay, one of them should succeed, correct? If you get either F1 or F1 dash, we are done. That's what it does. Assuming any given fragment may have been a part of either transmission. That means first fragment you may get F1, second fragment you may get F2 dash. It should be fine. At least one copy from here, you get it, then you multiply what is this probability, then you'll get the probability of success, right? Probability of success would be probability of success probability for fragment multiplied by success probability for fragment 2 multiplied by success probability of fragment 10. That would be the success probability of the entire packet. Now, how do you find the success probability of fragment 1? Fragment 1 will be successful if F1 is successful or F1 dash is successful. But don't work with R, because when we say F1 is successful or F dash is successful, you should also include that both F1 and F2, F dash are successful, right? But you work with the failure. Okay, fragment 1 will fail when both will fail, correct? When both are lost, fragment 1 will fail. One loss probability is 0.01. So 0.01 multiplied by 0.01, that is the probability that the both copies of the fragment will be lost. So when you do 1 minus of that, that will be success probability of the fragment. So you know the success probability of the fragment. You multiply the success probability of each fragment, you get the success probability of the entire packet. Then do 1 minus. When you do 1 minus, you will get the net loss of the packet. That's all. Correct? But if you want to check whether it is out of scope or in the scope, maybe you can check with Part 2 lecturer, Prof. Motani. Okay?
Okay.
And I think other questions should be there.
Yeah, I have no more questions.
Okay, good. Students, other students?
Wait, if we want a consult, right, do we write email to you?
Yeah, for short questions, yes. Okay. But what I would suggest is, I mean, I think I told in the lecture also, don't say, okay, question number, tutorial question number 5 or exam questions 2002 number 6 or something, because that will take some time for me to go and log into my computer and find out what you are referring to, right? But if you have a screenshot of everything you are working and the question and thing, I can even quickly look at my phone and answer you, right?
Oh,
When you ask questions, if it's a conceptual question, okay, that's fine. But if you refer to some lecture notes or some past year questions or some tutorial question, better send me the screenshot of that also, right? Okay. So then even if I am on travel in the bus or train, I can answer your question quickly. Yeah.
so Prof, we just WhatsApp you, is it?
Hmm?
Do we just WhatsApp you the question?
No, you can send it by email. I don't think I shared my phone number, right? Okay. You can send it by email. Anyway, is that okay?
Okay.
Any other questions, students? Okay, if there are no other questions, let me first stop sharing it. And students, can we end the session? Any other question?
Wait, can the cheat sheet be printed?
You mean the typewritten, is it? You want to copy paste?
Yeah. Typewritten.
I don't know what, I mean, Part2 lecturer, has he made any announcement in the class?
No.
Can you drop an email to him, copy to me? Yeah. Because sometimes I want to know what other lecturer has told. We prefer you to write it down. Okay. Because one purpose is for you to learn when you write down some important formula and other things. Okay. Rather than copy paste from the lecture notes, making it a very small font. If you write it, I mean, that will help you also. This is our recommendation, but I don't know. I have to, can you drop an email separately? Right. Okay. To both lecturers. Hmm?
Okay, I'll do it when I'm free.
Yeah. Yeah. Okay, students, I wish you all the best. And I think you are going to have exam next week, right? Not much time left. And prepare well for your exam. Okay, go through the notes and I think the practice questions, sample questions, quiz questions, and some past year questions, your tutorial questions, and the lecture notes. That should be adequate, should be helpful, very helpful. Okay? Wish you all the best. I'll stop here, and later I will, if you don't see the recording, if you don't have access to the recording, maybe let's say at the end of the day or today evening, please drop me an email. Okay. See you then. Bye.